This is the reaction of hydrogen peroxide. We have peroxide at home. We use it for cuts and such. It's usually in a brown bottle. And the reason that it's a brown bottle protects it from light. Yeah, especially fluorescent light or sunlight will actually cause it to decompose. The hydrogen peroxide will slowly decompose to form water and oxygen gas. And we actually see that when we pour it onto a cut. We see the bubbling action. That reaction's happening quite slowly. In chemistry, we don't really like slow reactions. We like fast reactions. So we're going to speed this reaction up. I'm going to take some hydrogen peroxide here. Now this is a little more active than the stuff at home. At home, you've got a 3% solution. Here, I have a 30% solution. Now, just so that we can see it a little better, I'm going to add a little bit of food coloring, like so. And when this reaction occurs, we're going to form lots of oxygen gas. So instead of just letting it go out into the atmosphere, we are going to trap the oxygen gas by adding soap. And this is just dish soap. So we'll add a little bit in there, like so. Now, right now, the reaction is going, but it's very, very slow. And we're going to add a catalyst to this. A catalyst speeds up chemical reactions. And in fact, really effective catalysts will increase the rate of a reaction 1 million to over 1 trillion times faster. And that's what we'll see here. We'll take a little bit of this. This is known as potassium iodide. It is found in sea salt, right? It's one of the components of sea salt. So we'll take some of this and add it to our hydrogen peroxide. We should expect an increase in the rate of reaction. So all of the oxygen gas bubbles are now being trapped inside the soap. You can see it steaming here. This process would have taken many years for it to entirely react. Here we were able to get it to react in just a number of seconds. So the use of catalysts, increasing rates of reactions in chemistry.